Hi everyone, what's up? All good? Great. So today we will be solving the problem of the day of GFG. So let's see what is this question. Minimum element in BST. Okay, so let's see what is this question. Given the root of a binary search tree, the task is to find the minimum valued element in this given BST. Okay, so you have been given with a tree and you need to find the minimum element of the tree. Okay, so let's see how we can do this question. So that we are given with this tree and we need to find the minimum element. So you can see here that the minimum element is 1. We can say that by just looking at this tree. Okay. Now how we can find the minimum element by the code. So one thing which first comes in our mind is that we can just traverse the complete tree and store all the elements of the tree in some data structure and then find the minimum element. Yeah, so we can first traverse this tree and store all the elements of the tree in some vector and then we can find the minimum element from that vector. Yeah, very good. Right. Yeah, right. So we can simply traverse the tree and then store all the elements and then return the minimum element from that their structure. Yeah, right. So how we can traverse the tree? So as we know that for traversing in the tree, there are three methods, that is in order, pre-order, and post-order traversal. So which traversal we should go with? So as you know that in order traversal stores all the elements of the BST in sorted order because in order traversal first we iterate to the left of the tree, then left, then left, then left, right? And then root element and then right element, right? So that's why in order element stores all the elements of the tree BST in sorted order. So we can do the in order traversal and then simply return its first element, which will be the minimum element of our traversal, right? Right. So yeah, first approach can be like doing the in-order traversal and then storing all the elements in the vector and then we can just simply return the first element. But its time complexity will be big O of n as we are traversing through all the elements, and space complexity will also be big O of n as we are storing all the elements in our vector. Okay, so let's see, can we save this space complexity? Yeah, we can save this space complexity. How? So instead of passing this vector, we can simply pass an integer result. And instead of pushing all the elements in our vector, we can just replace this statement by instead of passing all the elements in our vector, we can we can simply do res is equals to minimum of res comma root of value, right? Yeah, so it will save our space complexity of big O of n, then its space complexity will become big O of 1, right? Yeah, good. So we have find the minimum element in time complexity big O of n and space complexity of big O of 1. Now, can we reduce its space complexity? Sorry, can we reduce its time complexity more? Okay, so let's see. As you are given that the tree is a BST, not a BT. What? Binary search tree, not a binary tree. Okay. So what a binary search tree is? Binary search tree is basically you have root element and then root left element will be less than root element and right element will be greater than root element, right? So this is the main logic of a binary search tree. And to find the minimum element of binary search tree, what we need to do? We just need to traverse to the leftmost node of the binary search tree. Yeah. So what we can do is we can just simply initiate our temporary node pointing to root node and then go to the left, left, left till when it has some left node. And if whenever it have exhausted all of its left nodes, then we can simply return this node. Yeah. Okay, cool. So let's see how we can code this approach. So what we need to do is we just need to initiate our temp with root and need to traverse till temp has some left node, right? So we will just point temp to the left node. And if it has exhausted all of its temp nodes, then we will simply return its value, right? Let's try run this. Because we just need the minimum element, which will be the leftmost node of our tree. Yeah, it's working fine. Let's try submitting it. Yeah, cool. It's working fine. So what will be its time and space complexity? As we are traversing to the leftmost node of the tree. It means we are traversing only for the height of the tree times, right? We are not going to through all the nodes. No, we are just traversing through the height of the tree. So its time complexity will become height of the tree, and as we are not using any extra space, so its space complexity will be big of 1. Right? So this was a very simple and basic question of binary search tree. I hope you get it. But if you still have any doubts, then you can surely post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.